Hi, my name is Martin Richard. I work for the Canadian Space Agency on a payload called BCAT-C1, which stands for Binary Colloidal Alloy Test. C1 stands for Canadian 1. The BCAT experiment is led by the mission manager at the Canadian Space Agency. His name is Charles Gauthier, and the mission scientist representing the PI at all times with me is Lucino Cohen. And we work from the Canadian Space Agency near Montreal in Canada. The room there is called the PTOC, Payload Telescience Operations Center. And we interface directly with the POIC in Huntsville, Alabama. And when the crew has questions about the experiment, they talk to Huntsville, but we hear what they say, and we respond directly to POIC, and they voice the answer back to the crew. Sometimes when it gets complicated and the crew has more difficult questions to answer, they will enable us on space to ground so we can talk directly to the crew. It happens a few times here and there, but usually we interface directly with the HOSC in Huntsville, Alabama. What we do in BCAT is we study the behavior of colloidal samples. What does that mean? Colloid is fluid that has particles in it that we may not see. Everyday products are colloidal, like toothpaste, shaving cream, detergent, milk is even colloid. And the researchers want to find ways to extend the shelf life of some products and also understand the behavior of the particles inside these products. And probably for many of them, improve the manufacturing of those products. The particles that are in our fluids would sediment with gravity. They would go down the cuvettes, and this would not be representative of a long-term exposition to real life. So, an example, if you have a fabric softener in your laundry room, it will take months before the products sediment, and it will take months before you see the effect of time on it, but it will have an effect. Time will have an effect on your product. In space, we can simulate that with bigger particles in the fluids, and that's over 10 days approximately, instead of months. We can simulate aging of a product over 10 days. So that's what we try to simulate and track. The experiment consists of mixing the sample and following the evolution of the sample over 10 days by taking photographs of the sample every hour or so, and we see the evolution of the crystals in them. Actually, samples phase separate like oil and water, and then crystals start to form. And the challenge in this experiment is to obtain the optimal lighting orientation. We have a camera, the module itself, and a flash unit in the back. And we have to illuminate the sample at the right angle so we can see the crystals. Otherwise, the sample looks clear. It looks like water. So you need the proper angle, plus minus 5 degrees approximately, to see the crystals, and then the PI can determine the behavior of the sample over those 10 days. So crew members, the operations consist of mixing the sample, setting the camera and the flash, and once this is all set, it runs for 10 days automatically on the camera intervalometer, and we get the data after.